A 5.00 gram charged insulating ball hangs on a 30.0 centimeter long string in a uniform horizontal electric field as shown in the figure below. Given the charge on the ball is 1.00 microcoulomb, find the strength of the electric field. So we're given the mass. Mass of the ball is 5.00 gram. We need it in kilograms, therefore 5.00 times 10 to the power of 3 kilograms. And the length of the pendulum or the string is given, that is 30 centimeters. We need it in meters, therefore that will be 0.300 meter. And the charge is given, and that's equal to 1 microcoulomb. And from the figure we know that the angle is 8 degrees, therefore theta is 8 degrees. Alright, so the ball is hanging means it's stationary, and that means summation of all forces are equal to 0. And what we are required to find is the electric field. The horizontal electric field here. Alright, so summation of all forces must be equal to 0. That means summation of all forces in the x direction is 0, and also summation in the y direction is 0, because it hangs, it's not moving, stationary. Alright, so what forces are involved here? We need to draw the free body diagram first. So we have a mass of that object, of that ball, and therefore there will be gravitational force downward, mg. What other force do we have? We have electric field, and the charge is in the electric field means there is force exerted on it. So there is force, electrostatic force in there. What else is hanging from some ceiling here? That means there is tension. Tension T. Alright, if you draw a line parallel to the string, if this is a string, the angle here is 8 degrees, this angle has also to be 8 degrees, that's theta. Reason? Because this line is parallel to this line, and therefore this angle is equal to this angle, alternate interior angles. Alright, so now we have our free body diagram, and that means we can also have the components, the vertical component of T and the horizontal component of T in this direction. This is Tx, this is Ty. Alright, so what is summation of all forces in the x direction? That should add up to 0. What are those forces? The electrostatic force, which is horizontal, because the electric field is horizontal in this direction. There is a charge, so the electric field will exert a force on the charge. That is electrostatic force. Alright. And what is the horizontal component of the tension? That's going to be T sine theta. And that should add up to 0. Alright. So the electrostatic force is Q times E minus T sine theta is equal to 0. Therefore, the electric field is going to be E T sine theta over Q. Alright, so we know Q, we know theta, but we don't know T. So how do you find T? Let's utilize summation of all forces in the y direction. And what are the forces in the y direction? The forces in the y direction are T, Y, and mg downward. That's mg. Should add up to 0. And what is the ty component? The ty component is this component here. This is the angle. Therefore, ty is going to be t cos theta. That must be equal to mg. Just adding mg to both sides. Therefore, t is going to be mg cos theta. mg divided by cos theta. Alright, so instead of t here, I can use mg cos theta. mg over cos theta multiplied by sine theta over q. And that means E, instead of sine theta over cos theta, I can write tan theta. So this is going to be mg tan theta over q. Now just plug in the numbers. Mass is given as equal to 5.00 times 10 to the power of 3 kilograms. Tangent of 8 degrees. Divide that by the charge, which is 1 microcoulomb. 1 microcoulomb means 1 times 10 to the minus 6 coulomb. That will be the electric field in Newton per coulomb. Alright, so 9.8 is missing here. Gravitational acceleration. Times 9.80 meter per second squared times tan of 8 degrees. And that's equal to 6.89 times 10 to the power of 3 Newton per coulomb.